In the vast emptiness of space, a giant is hurtling toward us. An interstellar object over 33 billion tons heavy, far bigger than anything we've ever seen. What is 3IATLAS, and why is it defying all our expectations? This is the cosmic discovery that could change everything we thought we knew about the universe. At first, it seemed like just another comet on a routine journey through the solar system. But what we found is nothing short of astonishing. 3IATLAS isn't just big, it's massive. At a staggering 5 kilometers in diameter, it's thousands of times more massive than any previous interstellar object we've encountered. But it doesn't end there. This object has been behaving in ways that defy logic. A strange force seems to be pushing it beyond what gravity should account for. So what exactly is this behemoth? Could this be an anomaly in the cosmos, or something even more profound waiting to be uncovered? What if 3IATLAS isn't just a comet? What if it's something we've never even dreamed of? Let's take a closer look at why 3IATLAS is so unusual. Comets are often difficult to measure. They have a hazy coma of gas and dust that surrounds the solid nucleus, making it hard to distinguish their true size. Normally, the outgassing, the process where a comet's frozen gases turn into vapor as it nears the sun, creates a push, sending the comet off course. This is what we'd expect. But with 3IATLAS, something's off. Despite the visible outgassing, the comet's non-gravitational acceleration, the force pushing it beyond gravity, was surprisingly low. This tells us that the nucleus of Atlas is unusually dense, heavy enough to resist being pushed around by the jets of gas and dust. The result is a comet so massive it doesn't behave like any other we've studied before. And here's where things get even more interesting. If the nucleus is as heavy as we think, that means 3IATLAS's core weighs over 33 billion tons, and it's only the beginning of what makes this object a true anomaly. Could this dense, massive object be the key to unlocking a whole new understanding of how comets and even planets form?
Now, let's put 3IATLAS in perspective. When we compare it to other famous interstellar objects like Oumuamua and Borisov, the difference is striking. Oumuamua, the first interstellar object we discovered, was just 100 meters long, and its behavior had scientists scratching their heads. Borisov, another interstellar visitor, was more typical, with a size of about 1 kilometer. Both were much smaller and behaved more like normal comets, with outgassing pushing them gently along their paths. But 3IATLAS, it's on an entirely different scale. Its mass, size, and behavior go far beyond what we expected from objects traveling between the stars. With a diameter of about 5 kilometers, this is 5,000 times more massive than Borisov. This shift in scale makes it a rare and puzzling exception in the cosmic lineup of interstellar visitors. So why does 3IATLAS shatter the mold? And what could this massive outlier mean for our understanding of interstellar objects? What if 3IATLAS is telling us something about the nature of the universe itself, something that we've completely overlooked? Here's where things really get strange. One of the most baffling aspects of 3IATLAS is its composition. When astronomers looked closely at its materials, they found something that doesn't fit the typical profile of a comet. Instead of the expected iron-rich core, Atlas's composition revealed nickel without iron, a rare anomaly in the cosmos. This raised a significant question. Why is this comet so different from the others? Comets usually form in the icy outskirts of star systems, where elements like iron and nickel are found together. But Atlas seems to have been made from a different kind of material, possibly formed in a way that is totally unknown to us. Could Atlas be carrying materials from a far-off place in the universe that we've never seen? Or, more shockingly, could it be something that was intentionally crafted by a highly advanced civilization? What if this is not just an anomaly of nature, but something entirely engineered? Could Atlas be a clue to something far bigger than we imagined?
Now, let's venture into a theory that could change everything we know about planetary formation. Imagine a young star system, just beginning to form its planets. The gas and dust swirl around the newborn star, and while some dust particles collide and form small planetesimals, others remain scattered. This process takes millions of years. But what if, into this chaotic system,
a large object like 3IATLAS falls in. Astrophysicist Suzanne Falsner has a bold idea. Atlas could be a planetary seed. Instead of waiting for dust particles to collide and slowly build a planet, an object as massive as Atlas could act as a ready-made core that immediately starts pulling in gas and dust. This could speed up the process of planet formation dramatically. Could Atlas, or objects like it, be responsible for the creation of gas giants? Could it be the missing piece of the puzzle in how planets form, both in our solar system and beyond? What if Atlas isn't just a visitor from another star system? What if it's playing a crucial role in the birth of new worlds? Here's where things get even more puzzling. Statistically, we should be seeing far more smaller interstellar objects before encountering one as massive as Atlas. But so far, that hasn't happened. If Atlas is truly as large as scientists suggest, why didn't we first encounter a parade of smaller visitors? Where are the intermediate-sized objects, the ones that would fit more neatly into our expectations? The rarity of such large interstellar objects raises a crucial question. Are we missing something about the way these objects form or travel across the galaxy? Could there be some hidden factor that prevents smaller objects from reaching our solar system? Or are objects like Atlas incredibly rare, possibly even the product of an unknown cosmic event or anomaly? The more we study Atlas, the more we realize that it might be an outlier, not just in size, but in the very way the universe builds and sends objects our way. What if Atlas isn't just a rare exception? Or worse, what if it's the beginning of something bigger that's already on its way? As if this cosmic mystery weren't strange enough, Avi Loeb, a prominent astrophysicist, has suggested something even more radical. What if 3IATLAS isn't a natural object at all? What if it's technological in origin? While the idea might sound far-fetched, Loeb points to several peculiarities of Atlas that don't quite match our understanding of natural objects. For one, its unusual trajectory and unexplained acceleration could imply something engineered, perhaps an ancient probe or even a piece of interstellar technology. And then there's the mysterious presence of nickel without iron, which Loeb suggests could be a sign of manufacturing far beyond what we see in typical celestial objects. Could Atlas be a message in a bottle from another civilization, hurtling through the cosmos for reasons we can't yet fathom? Or is this just an overreach, an example of humans projecting their own desire for answers onto the unknown? What if Atlas is part of something far bigger, a secret we're not ready to understand? As Atlas races through our solar system, astronomers have pinpointed key milestones that will give us a rare opportunity to study this enigmatic visitor in detail. The first major event is its flyby of Mars on October 3, 2025, when the comet will pass just 18 million miles from the red planet. NASA's MAVEN and the Mars Express spacecraft will capture detailed images and data of its coma, its dusty glowing halo, never before seen at such close range. But the real excitement comes when Atlas reaches its perihelion on October 29, 2025, the point where it comes closest to the Sun. As it swings behind the Sun, its speed will hit an incredible 152,000 miles per hour. Unfortunately, the comet will disappear from Earth's telescopes, hidden behind the solar glare. However, spacecraft at L1 and Mars will keep their eyes trained on Atlas, providing us with a final glimpse of this mysterious traveler as it speeds past. As Atlas nears its closest point to the Sun, we'll witness something even more startling: jets of vapor erupting from its surface, revealing secrets about its core. But what exactly will we find? As 3I/Atlas completes its brief, dramatic journey through our solar system, it will ultimately vanish back into the dark void of interstellar space. By March 16, 2026, it will pass by Jupiter, and then, after one last glimpse, it will be gone forever. The data collected will be invaluable, but once Atlas speeds past, there will be no way to reach it again. Its secrets will remain locked away in the silence of space. For astronomers, this will be the culmination of a once-in-a-lifetime opportunity to observe an object so massive, so strange, and so mysterious. For all of humanity, Atlas's brief encounter with our solar system will leave us with more questions than answers. And perhaps, just perhaps, it will force us to reimagine our place in the cosmos. Atlas's final departure into the unknown will leave behind terabytes of data, but the mysteries of this interstellar visitor will likely linger in our minds forever. Atlas may be gone, but what if it's not the last of its kind? What if this is just the beginning of a new age of interstellar discovery?